What's up, me students? Thanks for being here. So we are looking at solving inequalities, 4.3 rational inequalities. Possibly did 1, 2 in class. So we'll come back to that one. We're going to probably just start with number 5, since it's already factored out for you there. No, maybe we'll do 6 actually. You need to factor first. Make sure that it is greater than or equal to 0. So we're going to go back to 3 or 4 and take a look at when it's not. But basically 1, 2, 5, 6, they kind of follow the same process. So greater than or equal to 0 means what? What is greater than 0? So positive numbers are greater than 0. So that's the key that we're looking for there. Where does this equation be positive? Where is it positive? So first of all, we start with the top, which is our x plus 6. And we want to see where it's greater or equal to 0. So we minus 6 to both sides. And we get negative 6 as our key there with the equal to. And so then we'll go ahead and do a number line with negative 6. Is it open hole or close hole? Well, because it's equal to, what is it? Equal to means close hole. Good. Awesome. So then, let's see here, the bottom now. So the bottom is more the exclusions, right? The vertical asymptotes. And so it can't ever be equal to that number because that's actually a exclusion. But we can still do something with it. So we got 8 times 3 is 24. Yeah, Merkley? Yeah, quality video. Because inequalities are tough. I can actually pause it for a second. We are back. Here we go. It's Mr. Merkley in the house helping us. He reminded me about probably writing some steps for you people at home to make sure you guys are getting this right. So he said, Merkley's rules, steps. So step number 1 is to factor it if any factoring needs to be involved. So then we got step number 2. And so step number 2 after we factor it. So then step number 2 is to set the top equal to 0. And step number 3 is set the bottom not equal to 0. Nice. Not equal to 0. And then graphing on the number line there. So graph on number line. So far we've done, so far we're factoring it and top equal to 0. And so after we factor it, so we do need a negative 8, and a positive 5. So then we set those not equal to 0. So that means x can't equal a positive 8. And remember, change the sign. Green, negative 3. And cool, so then we're also going to graph those. So we got a negative 3 here and an 8 here. And since they're not equal to negative 8 or 3, is that an open hole or a closed hole if it's not equal to? So not equal to is an open a hole. Excellent. Okay, so graph on the number line. The bottom will always be, because you can't have 0 in the bottom. So the bottom is what? Always open hole. And sometimes the top's open hole, depends on equal to or not. Always open hole. And so if it's equal to, then the top is also, then top is a closed hole. So top is if it's equal to, if it's less than or equal to, greater than or equal to, so then it's an open hole. Otherwise, if it's like that, then it's a closed hole, right? And if we're trying to keep things the same, there you go. Yeah, so the equal to determines if the top is open or if it's closed. Oops, reverse it. What do you mean reverse it? I mean equal to means closed hole. That's it. And not equal to, just greater than or less than, means open hole. That's better. Cool. Okay, and then number 5 is decide which of the intervals is right, whether it's all the positives or all the negatives. And then that's your interval, and that is your answer. Whoa, class starting? Not yet. Cool. Second lunch. Okay, excellent. So then what we're going to do now is we have to do step 5, actually. Whoa, there's more to step 5? Yep, so this was actually step 6, Nubo. Sorry. So that's step 6. And so step 5 would be actually to do your test points and determine which stuff is positive and negative. Cool. So then test points. You're going to choose numbers basically that are in between these intervals. So between -3 and 8 is a 0. And so a 0 would be definitely a good test point, right? 0 would be definitely a good test point. Awesome. So we're going to plug 0 in and see what happens. So we'll plug in a 0 here, and we get a 6, or a positive number, or a positive number on top is what we're saying there. What happened? Sorry, smartboard's acting up again. Naughty smartboard. Bad smartboard. Spank your board. There you go. Be good. Okay, so then we have 0 plus 6 is just 6 all over. And if you think about it, these zeros are just going to be a -24 left, because, yep, -8 times 3 is -24. Cool. So then we just have a positive over a negative, which is just a negative number. So this will be negative, going in that direction. We do want to choose a number greater than 8. So, for example, 9 or maybe 10, whatever's easiest. Let's say 9. So then we go back to our original again, and this time we're putting a 9 everywhere. So then when we do that, 9 plus 6 is 15. So this is our test point using x equals 9. So then we have 9 plus 16. Sorry, 9 plus 6 is 15. And then we have 9 minus 8 is 1, and 9 plus 3 is 12. So positive 12 on the bottom. So positive over a positive is a positive. So that means this side over here above 8 will be positive. And then we're going to guess maybe this is positive, this is negative, you know, but we'll see in a second. So we got to use another test point now. So a number between -3 and -6. So what's that maybe? -4? Sure, why not? So let's try -4 now, plugging it in. So now we're going to do -4 into the original, which means putting it right here, right? -4 plus 6. All over, and then let's see here. Whoa, Newbold, you just erased the whole thing. Sorry. Did it bring it back? Yeah, it did. Okay, there we go. So now instead of putting 9s there, we're going to be putting -4s there. So -4 minus 8 is a -12. And then -4 plus 3 is a -1. And so then we have 6 minus 4 is 2, which is positive. And then on bottom, negative is a positive. Ha-ha! So because we have positive over positive, then we were right. This is positive, this section. So definitely right positive. And then hopefully this one over here will be negative, would be sweet. So below -6 would be like -7 or -8. Let's use a -8. So now we're going to put a -8 here instead of a -4. Awesome. And then -8 here. -8 minus 8 is a -16. And then a -8 here, so that'd be -8 plus 3 is a -5. And so then we do have a positive on the bottom. That'd be like -21. And on the top is a -2. And so that means it will be negative then, because a negative divided by positive is a negative. Cool. So let me go back to the original, and we're looking for all numbers greater than or equal to 0. And so positive numbers is the key. And so our positive intervals will be this answer. A -6 starting, and then positive, 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 till we get to -3. And then because it's a open hole, that means it's a parenthesis. In union with, this is negative, 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 so we don't want that. And then starting at 8 now, and then to the right. So 8 in parentheses. Good. And then comma. And then to infinity to the right, positive forever. Cool. So that is our answer now. Right? I just got rid of all the pluses and minuses. I do apologize. Okay, so that is our answer, and I'll carefully circle it better this time. Okay, so there's our answer, -6 to -3. So that's basically shading, you know, from this guy to this guy, and then shading from this guy to the right, to infinity, positive infinity forever. Cool. So that's how we do this amazing rational inequalities. So let's jump to maybe like question 4, where it has a number on the other side. Okay. So number 4, here we go. So number 4, let's do step. So no factoring, done. What's our steps? Do you remember our steps? So factor it, done. Set top equals 0 and bottom not going to equal 0. Well, there's a step number 4.5. What the? Okay. So we actually have to do something else first when there's not everything on the same side. So this would be like step 2.5. Dang you, Newbold. Sorry. So get everything on the same side. Everything on same side. And then get a common denominator. So many steps. More than I thought, I guess. And so get everything on the same side. And then get a common denominator. Wow, Newbold. Wow. Okay, it'll take some practice, but you'll get it. Okay, so in this case, we want to get everything on the same side first. And so I labeled that as 2.5. But really, this should move up to, wow, Newbold. Sorry. So 1.5 really is where this should fit after you factor it. This might even be before factor. This is like step 0, Newbold. Sorry. So this is like step 0. Excellent. And so step 0 is to do this. Get everything on the same side. Get a common denominator. So let's try that with question 4 now. So we're going to go to -5 to this side. Right? We're going to go ahead now and minus it to this side like this. So then we're going to go and get x plus 68 all over x plus 8, and then -5. Cool. And so it's greater than or equal to 0, and that's what we wanted. Now we do have to have the same common denominator. So we're going to have to go in and divide that 5 by 1, because any whole number can be written over 1. And to get a common denominator, we're going to have to multiply the bottom and the top by what? X plus 8. Awesome. So now we do have finally a common denominator. We have x plus 68, right? And then we have a minus 5x, because -5 times x is minus 5x. And then a minus 40. -5 times 8 is -40. Good. And then all over x plus 8, because we can combine the top over the bottom once. Back to adding rationals. Cool. So then combining like terms, we get 68 minus 40 is 6 minus 4 is 2, so 28. And then an x with a -5x is a -4x. So we get -4x, and then we get plus, and then 28. Because -68 and positive 68, -40 is positive 28. Cool. All over x plus 8. And so this is what we're going to use now and set it greater than or equal to 0. Cool. Okay, so then we want to set the top equal to 0. Next. So our top is -4x plus 28. -4x plus 28 equal to 0, or less than or equal to 0. And then we're going to minus 28 to both sides. Good. So -4x is equal to -28. Then we're going to divide by -4. Divide by -4. So, and when we divide by 4, we get a negative divided by negative is a positive. X equals 7. So there's one of our values on our chart that we're going to do. So we'll go and draw our chart down here. So at x equals 7 is one of our numbers. And then we just have to set the what? The bottom. Not equal to 0. And so we get -8. So we're going to go in and put a -8 over here. Okay, so the -8 is not equal to 0, so open hole. And the next equal to 7. Let's double check. Oh. Yep, less than or equal to, so we can do a closed hole there for number 7, which came from setting the top equal to 0. So after we set the top equal to 0, we set the bottom equal to 0. And so setting the bottom, or not equal to 0 actually, because it's an exclusion. And so when we do that, we get minus 8 to the other side. Cool. So open hole at negative 8. So now we just need 3 test points on this one. So let's choose some test points here to plug in back into the original. So maybe it'd be fun to do 10 or 9, maybe 10. So let's go ahead and do a different color to show you now that we're doing test points. So maybe choose, choose negative 10. Right, it's a test point to see if it's positive or negative up there. Excellent, and then what are we going for? Well, it's less than equal than negative 5. Less than means we're going for the negative numbers. Negativo is what we're going for. So we'll talk about, so that means wherever this is negative, we'll include that in our interval. Is it all 3? Is it only 1? Is it 2? So we'll see in a second. So now we're going to use negative 10 and plug it back into the original. So we're going to go negative 4, so negative 10. What are you doing, Newbold? Using the colors. So we have negative 4 times negative 10 plus 28, using the original, all over x plus 8, where x is negative 10 plus 8. Cool. So negative negative is a positive 40. Now really, you don't have to put those together and get 20 and get 68. No. But what you want to do is just see if it's positive or negative on top. And it's positive on top, and then on the bottom would be a negative 2, so it's negative on the bottom. So positive divided by negative is a negative. So this part's negative right there. Let's choose a number between negative 8 and 7. 0 is usually the easiest. So now I'll plug in a 0. See if we can do that in our head or not. So this will go away, and this x will go away. So we'll be left with a positive over a positive. And so when we use a test point of x equals 0, test point, we get positive over a positive, so 28 over 8, which is positive. Then we just get positive. So positive is next, and then you probably will guess it. If we plug in an 8, maybe we'll get negative. So we're going to go and do another test point. So the one test point we did here was 0, and now we're going to do a test point of maybe 8. So instead of plugging in a 0 now, okay, so now we're going to put in a positive 8. So positive 8 times 4 is negative 32. And negative 32 plus 28 is going to be a negative number. And then we'll plug in 8 here. 8 plus 8 is 16, which will be a positive number. Negative divided by positive is a negative. So we got a positive, negative is what's going on. Now, according to our problem, we're just looking for negative numbers less than or equal to 5, so negative numbers. And so our negative numbers would be open hole at negative 8 going in this direction, and close hole at 7 going in this direction. And so those are going to be our two answers. We're going to write an interval notation. So we're going to go from negative infinity to open hole 8, like that, in union with bracket, including the 7, to positive infinity. Woo! We got it. So a lot more work than I thought. Definitely more room on this worksheet next year. So thanks for watching, and keep on hard on solving inequalities. You got this. Do it. You got this.